All right, welcome to lesson 3, everybody. So far, we've talked about gas, liquid, and solid, temperature change, kinetic energy. In the first lesson, we talked about what an ideal gas is, Boyle's law and Dalton's law. And remember, Dalton's just a change of Boyle's, and Boyle's is how volume and pressure affect each other. Well, today we're going to do Charles's law, and we're going to do the combined gas law. Charles's law says that the volume of a quantity of gas held at constant pressure varies directly with the Kelvin temperature. Remember, the first lesson talked about kelvins. And the important thing about kelvins is that there are no negative numbers. So whatever your degree C, if you're given a degree C, just add the 273 to it. Okay? And that'll give you kelvins. Notice here you've got V over T. This is called a direct relationship. We know that as temperature goes up, the volume will also go up. Think of hot air balloons, okay? They shoot hot air into it, and they shoot the fire into the balloon, and the air expands, and it increases the volume inside the balloon. So this is a direct relationship. If we had 1 over 2, and I changed it to 2 over, in order to stay the same, that would have to be 4. So increase, increase. So this is our Charles law. V1 over T1 equals V2 over T2. Okay? So when we try it, we say, okay, well, what do we have? We've got 225 cubic centimeters at 58 degrees. The first thing I do is do this. Convert degree C to kelvins. Kelvins equals degree C plus 273. So K is equal to my 58 plus 273. My kelvins equal 331. And it's not degrees, it's just kelvins. So this is 331 kelvins, and that's T1. This is V1. What volume would this sample of gas occupy its standard? Remember, we have STP. STP, standard temperature pressure. Standard temperature was pressure is 101.3 kPa, and standard temperature is 0 degrees C. So our standard temperature, 0 degrees C, 0 plus 273, 273 kelvins. And that is T2. Okay? So now we set up Charles' law. We say V1 over T1 equals V2 over T2. We've got V1, 225, over T1, not the 58, the 331, equals V2 over standard temperature, 273. Now listen, we talked about isolating any variable. When you've got something over something equaling something over something, what you need to do is cross multiply. The key is to get everything on one line. We don't like fractions. Keep everything on one line. Now, to get everything on one line, you cross multiply. So I'm going to multiply the top of one by the bottom of the other. I'm going to take the bottom of the first and do the top. So I've got 225 times 273. That's going to equal my V2 times 331, right? So we just cross multiply the top of one times the bottom of the other. The top of one times the bottom of the other. Now we isolate. We say divide by 331. Divide by 331. Cancel, cancel. V2 equals 225 times 273, enter, divided by 331 gives you 185.6. Now that is volume. We don't have a unit here. The volume 2 unit has to be whatever volume 1 is. Centimeters cubed, cubic centimeters. So when it is a volume of 225 at 331, we lower the temperature to 273. Our volume goes from 225 down to 185, a direct relationship. Okay? So these problems here, this is V1, this is T1, this is T2. Okay? So the first thing I'm going to do is I'm going to add 273 to this. I'm going to call it 296. Okay. So V1, 2.9 over T1, already in kelvins. Tricky, tricky, tricky. 226 equals V2 over T2, 296. Okay? Cross multiply. Those two go together. So I end up with 2.9 times 296 equals, these two get multiplied, V2 times 226. Divide both sides by 226 to isolate V2. So this cancels. This equals V2, 2.9 times 296, enter, divided by 226 gives you 3.8. Now, what's the unit? The unit for V2 is the unit for V1, meters cubed. 3.8 meters cubed. So, the temperature went up, 226 to 296. The volume went from 2.9 to 3.8. Volume up. Direct relationship. Okay? I'm going to leave you these and these. These were the practice for Charles's Law. They are part of your notes. The answers can be found in the completed notes, same on the day 3 lesson. Okay? So that's Charles' Law. That's some practice you can practice up. Lastly, you got the combined gas law. Okay? Now, the combined gas law should look pretty something. I can't even think of the word. Familiar. Should look familiar. Basically, we have volume, pressure, temperature. We put all the ones on one side. We put all the twos on the other. Now, if you remember, That is Boyle's law, right? And then this and that's Charles's law, the one you just learned about. Okay? So it's a V1 P1 equals V2 P2. And Charles is V1 over T1 equals V2 over T2. So if I take my VP and my V over T, I get that. Same thing on that side. Okay? So, just putting them together. You got this. Let's see what we have. 10 centimeters of gas. That's a V. Is measured at, that's a P, pressure. That's a temperature. That's T. So it's this much volume at that pressure and that temperature. That's what makes them all the ones. Is to be corrected to correspond to the volume it would occupy at STP. STP, not standard pressure, standard temperature pressure. So my standard pressure is 101.3 kPa. My temperature is 0 degrees C. Okay. This is where you forget. You got to remember you have to use kelvins. So in order to use kelvins, I've got to convert. So kelvins equals degrees C plus 273. So for T1, kelvins equals 60 plus 273, which is 333. Okay, that's T1. T2, kelvins equals 0 plus 273. That equals 273 kelvins. That is T2. Okay? So that's the first thing you ought to do. Once you get used to it, I just cross it out here and put 333. And I cross this out and just write 273K. I don't do that. I'm just showing you how it's done. Just do this in your head. If you see a degree C, cross it out. That's all. Okay, so you can do this optional step if you want to organize. See how these three go together. 10 centimeters cubed, 75.6 kilopascals, and 333K. Your V2 is your unknown. Your P2 and T2 are your standard temperature and pressure, 101.3 kPa and 273K. Okay? So that's it set up, organized. Remember, V1, P1 over T1 equals V2, P2 over T2. Okay? So all we do now is we fill in what we know. Okay? What do we know? V1, 10 times P1, 75.6 over T1, 333. That equals V2, our unknown, times 101.3, that's our P1, our P2, over our T2, 273. Okay? So, in order to isolate the variable, you've got to get everything on one line. Cross multiply. So I'm going to take the top of 1, 10 times 75.6 times, so 10 times 75.6 times 273, that's going to equal V2 times 101.3 times 333. Okay, how we looking? That good? All we're doing is setting it up from our cross multiplying to get in a line, and we're going to isolate V. Once you get it all on one line, as opposed to something over something, once you get it all on one line, now whatever's next to your unknown, if it's multiplied, you divide. If it were underneath, okay, it won't be because it's all on one line. So I'm going to do 101.3 times 333 here. That allows me to cancel this side, leaving V2 by itself. What I do to this side, gots to do to this side. 101.3 times 333. So, what do I have left? Equals V2 on the right. 10 times 57.6 times 273. Enter, enter. Divided by 101.3, enter. Divided by 333. Should be 6.1. Volume 2 is the same unit as volume 1. Centimeters cubed. Okay? Now, if you get the answer, to be 6, 7, 8, 4, 5, 2.2. If you get that answer, which is kind of just a little bit out wrong, what you did is you did 10 times 75.6 times 273, enter, and then you took that number, that answer, and divided by this times this with no parentheses. Remember, your calculator puts that number in its little brain. It divides it by this, but if you just put divided by 101.3 times 333, boom. It takes that top number, divides it by 101.3, and then multiplies it. Remember when we were doing stoichiometry, right? So I suggested 10 times 75.6 times 273, enter. Divide by 101.3, enter. Divide by 3.3, 333, enter. Okay? So just remember back to stoichiometry. So that's that. There are 4 problems here. I'm going to let you go ahead and work on those. I'm going to have you check the answers on the completed notes. They're there. Once we got these down under our belt, practice. There's 2 practice worksheets. One of them is a little story time. And don't forget about the gas simulation. The gas simulation is open. I need a picture at the end. I've been very specific on how I want it submitted, so do your best to turn it in the correct way. The test will open on Thursday and be done by Sunday. Thank you to everybody that's watched these 3 lessons. I hope you learned something. I hope you're keeping up. Hope you're doing your best. And hope to see you soon. See you at office hours. Bye-bye.